Yeah. So, yeah, I cannot speak with that. So I need to take it off. So, yeah, thank you. Thank you for the introduction. And yeah, I'm going to speak about iOS investigation. So I just need a few seconds. So I need to speak to remove all the cable on me. So about me, short introduction. My name is Paul. I like to reverse malware and to build stuff like this stuff. I did it by myself. So you've got a picture of me when I had to reverse Delphi or VB binary, or when I create this kind of mask. And I work at Cisco Talos for 3 years, I think now. Mainly work on malware analysis, APT actors, and stuff like that. I work on the talk you saw this morning about DNS espionage, CTurtle, etc., etc. So just a statement about my talk just now. I will speak about iOS, not about iOS. So if you expect a talk about the Cisco operating system, it's not the purpose of my talk. I will speak about the OS developed by Apple on iPhone, iPod, iPad devices. So if you expected something else, you can change the room. Hopefully you have 2 tracks. I won't give you any 0 day on iOS, because if I had 0 day, I would be really rich and not here. And I'm not a big expert on iOS stuff, so I touched my first iPhone a little bit more than 1 year ago. So I'm really newbie on this domain. I'm not involved on jailbreak community, so I'm not developed jailbreak or stuff like that. My goal was we had to work on some investigation on iPhone devices, and I was a little bit lost, because if you try to find documentation on Google, like how to do forensic, how to analyze malware on iOS, iPhone, and stuff like that, you don't find any stuff. You find a lot of stuff about protection, about how works the last jailbreak, how works the last vulnerability of this device, and you can find this kind of stuff, no problem. But if you want to work from a defense point of view and from I've got some suspicious about this device and I would like to investigate if something is wrong, you don't really have a lot of documentation, because as malware does not exist on iPhone, you don't need documentation. So that's the purpose of my talk, is more about a feedback about how I worked, what kind of tool I used, what limitation I have when I have to work on iOS device, etc. So small agenda. I will really quickly introduce you the iOS architecture, because it could take hours to speak about how it works, but simply to give you a small overview, and you will be able to understand the rest of the presentation. I will have a part about jailbreak, because jailbreak is part of the system. I will explain you why you should or you should not jailbreak your phone, and the limitation of the limitation imposed by Apple when you have to do forensic, and how to bypass this limitation by using a jailbreak. I will present you the tool I use, so no magic tools, it's really common tools, but I will explain you how I use on my specific context, which was iPhone analysis. And after, I will explain you how attackers can deploy malware on iOS devices. It's based on real case, so I will not show you something new, but something they already used for a couple of years. And finally, I will show you from a malware analysis point of view what a malicious developer can do on malicious iOS application, because it's not like on Windows system. You cannot make the injection of remote process, parse the memory to find I don't know, credit card number or whatever. It's technically impossible on iOS devices. So I will show you what we saw, what really exists. And you will see, even with the limited feature provided by Apple on this domain, attackers can make some fun stuff. So first things, iOS architecture. So it's a Unix system. So you can have directly a terminal, having classic command like ls, ps, extra. You have file system. It's really a Unix system, really close to macOS Unix system. You have several layers, like on every operating system. You've got the user land where the application is executed. You've got a couple of frameworks to help developers to develop iOS application. But you have private framework. It's framework used by the operating system, but the developers don't have access to this framework. You cannot develop your application and say, yeah, I want to use this private framework. No. It's closed and you don't have access to that. You can develop your application in Swift or Objective-C. And you have a lot of third-party library. For example, iOS really love SQLite database. So more or less everything is an SQLite database on the device. So you need the library to be able to read this database. So they provide library. Almost everything from a configuration point of view is on XML. So you have a library to parse XML configuration file and stuff like that. And after you have all the library for memory management and sandbox, because every application on your phone is blocked inside of a sandbox. So Apple developed a library to manage the sandbox. And finally, you have the kernel. So it's really classical layers. The only big difference between that and a Linux system, if you wish, is everything is really separated and you only have access to the libraries that Apple decided you will have access for your application. So, Apple does a lot of effort to provide a secure operating system. So they put a lot of different layers to block access to a really important part of the operating system. They think you don't need to have access. First thing, for example, you cannot be root. You cannot have a root account on your phone. It's not possible. You cannot have the UID 0. You don't have a direct access to the file system. You cannot go on /tmp/ whatever. It's technically not possible. When you have an application, they create a file system for the application. You can go inside of your directory, but that's all. You cannot go on directory of other application, and you cannot go on the system /user or stuff like that. It's not possible. You have a virtual file system for your application. Sandbox, as I mentioned, every application is executed inside of a sandbox, isolated from the other application. The root file system, is in read-only. So even if you find a way to escape the sandbox, and you find a way to become root, you cannot modify the file system. It's in read-only. And finally, you have code signing. Your application must be signed correctly to be executed. It's not like on Microsoft. Microsoft, you should be signed, but if you're not signed, it's not a big issue. Here, if you're not signed by a good certificate, you cannot execute the binary. It's easy. So it's really good from a security point of view. They had so many layers of securities, and it's really complicated to be able to become root, make a bad application, become root, put a malware on the file system, extra. It's something really, really complicated. So from a security point of view, and my point of view, it's a lot of good choice. But the limitation is when you want to do forensic analysis. When you have a phone, you know it's compromised for whatever reason, and you say, okay, I would like to check what happened on my phone. Because you will have all this limitation for you, even if you are a good guy and you want to do something positive. That's why I will speak about Jailbreak. Is it mandatory or not? So the answer is yes. You need to jailbreak your device to work. For example, you can imagine you have devices, you know it's a malicious application, because, I don't know, it was downloaded somewhere or it was not here, and you wake up one morning and bam, a new application. You have a big suspicious, it's not normal. If it's technically impossible to get the application. the file system, the directory where the application, the binary code is stored on the device is not reachable. You cannot access to this repository. You can access to the data, but not to the binary. So if you do a backup of your phone, for example, he will back up all your data. So if you have a new phone, he will restore the data. But on the Apple philosophy, you don't need a backup of the binary, because the binary will be back from the store later when you restore a new phone. So you don't need to back up the binary. So you don't have access to the binary. It's something new. This limitation appears on iOS 8. It's impossible to dump the memory. As you are located inside of a sandbox, you could imagine I can dump the memory of my sandbox, but not the memory of other process. It's not possible. You cannot dump the disk, as I explained. You are limited to the data that Apple allow you to have access. For example, if you want to debug an application, if you already have the application, you can modify the application and debug it on a device without jailbreaking the device. If you don't have the application before, it's impossible. It's limited by Apple security. So let's speak about jailbreak. What is a jailbreak? Is a couple of vulnerabilities that allow you to have a full access to the device. So imagine I describe you a lot of protection just here. So when you execute a jailbreak, it means it's an application that have a vulnerability on the kernel that allow to execute something as root, and they find a trick to remount the file system in read-write in order to drop something in this file system, bypass the signatures, and you finally have a jailbreak. So today, the application I list here do all these tasks for you, but it's a lot of different tasks, and it's a lot of different combined exploit or weakness to achieve this task. So today we are able to jailbreak from an OS point of view all the version until 12.4. So if the OS is more recent, if you the people that own the phone you want to analyze is up to date, you cannot jailbreak the phone. I will explain you some new stuff just after. So for up-to-date device, you only have two solutions. The first one is to ping Celebrate and be prepared to pay a lot of money. And the second solution, the more realistic, if you don't have a lot of money, is to freeze the phone, to stop the phone, to put a fake profile. For example, you can say on your device, no, in fact, I'm not an iPhone, I'm Apple TV. And by doing that, you block the update system of Apple. And wait for the next jailbreak. You don't have other solutions than wait for a jailbreak if you want to perform a forensic investigation on the device or get install application or whatever. If you want to create a lab, because you want to practice before having a big issue, it's always better, trust me. You would like a phone that you can jailbreak. You would like a specific version, because you don't want to have a iOS 13 and you cannot jailbreak it. You need to wait for the next vulnerability, and this time you will be able to jailbreak extra, so you will lose a lot of time. The best way I have for you is, in fact, you would, I did it. You will look like a little bit crazy, but it works. When you go on the shop, you take the serial number on the box, and based on the serial number, you can guess the date of the creation of the phone, when he was got from the factory. And based on this date, you can guess which operating system is installed on the phone. For example, here, if you have a serial number that starts by something, WW something, and CCCC, it means it was created on the first half of 2018 on the week 25. That means it's probably installed this version of iOS on the phone. So the only stuff is when you go on store and you say, yeah, I would like an iPhone X with a serial number when the third and fourth number are A and C, you looks like a little bit weird. But finally, if you pay, the guy is okay. And that's how I'm sure I have this specific iOS version on my device, and I can jailbreak it. So another solution is to go on eBay. A lot of guys block the update and try to sell it on eBay, but it's fucking expensive. And this technique is you pay the real price of the phone, not the double like you can see on eBay. So the website is this github.io website if you want to know and it automatically gives you more or less the iOS version installed on the device you want to buy. Yeah, so a few weeks ago, something changed on the jailbreak stuff. So a vulnerability was released named Checkmate, and it changed the game. So someone found a vulnerability on the firmware part of the device. So he found a vulnerability somewhere on the device where Apple is not able to patch. So today, all the phone from iPhone, if I take iPhone, but same thing for all the device, iPhone 8 to X, all these devices are vulnerable to Checkmate, and all these devices can be patched, because it's a hardware vulnerability, and it's on the chip inside of the phone, and it cannot be patched by Apple. What is this vulnerability? This vulnerability is on the iBoot. iBoot is how the iPhone boot. It's the code that will take your OS and load the OS in memory and start the OS. Why it's a big change? The iBoot is a part that checks the signatures of the operating system. It means we have a vulnerability in iBoot that will allow you to boot a not correctly signed iOS operating system. So it's not a jailbreak. It's simply you have the control of how your device boot. And you can modify the boot. You can modify the memory and say, I want to boot in debug. You can normally load a custom ROM. A lot of people started to boot very old version of iOS, which is impossible because when Apple revoke a certificate, you cannot boot old version anymore. You need to have the latest version of iOS, and you cannot downgrade. For example, it's not supported. You cannot downgrade a phone. But with this vulnerability, you can bypass the check and say, I want to downgrade my device, and it works. So it's really a game changer from a jailbreak community point of view. And another group of people starting to write a jailbreak named Checkmate that use the Checkmate vulnerability. And the biggest change is, as we are speaking about hardware vulnerability, you can jailbreak any version of iOS, even the last one, because it's modified before the load of the operating system. So now you have jailbreak on OS point of view. Today, the last one is 12.4, and you have jailbreak from hardware point of view from 8 to X. So that's already in the past it was a little bit complicated, but now it's more complicated because it depends on the hardware and stuff like that. So yeah, I'm going to try to show you. I'm not sure it's going to work because the exploit is not 100% stable. So yeah, something. For this exploit, I read a lot of bad newspapers that say bullshit. Yeah, it's part of our life, I know. So some newspaper explain, yeah, don't use a random charger for your phone because they can use this vulnerability, blah, blah, blah. The vulnerability only works in DFU mode. It means in restore mode. So you must switch off your phone. Sorry. And once your phone is switched off, you must boot in DFU, which means you must push a level down and click on the button, the power button. And normally I am in DFU. Let's try. No, it failed. Let's try again. So yeah, if you use your Uber cable, except if you reboot, switch in DFU mode extra, he cannot use checkmate on your phone. So don't be paranoid. But if someone has physical access to your phone, yes, he can do it. I'm not in good mood. Anyway, I don't. Even if I want to, I've got some issue to boot in DFU. So basically, the purpose is you boot in DFU, you use the exploit, and you have GDB, so the classical debugger, on your iBoot, and you can debug step by step the boot of your operating system. You can modify memory, you can modify a register value like a common debugger. So it's really useful if you want to understand how boot an iOS, and it's also really useful if you want to modify the boot behavior. For the moment, it's only in memory, so it doesn't break your phone, you know. The exploit modify memory and that's all. But something you can do is to overwrite the iBoot and put your own bootloader. Yes, in this case, you could break your device. Anyway, let's come back on malware analysis and stuff like that. First thing, if you want to decompile, disassemble an application, IDA Pro will give you good results, but it's expensive. And today we have two alternatives, really good one. The first one is Hopper. You need to pay it, but it's like €100. It's not really expensive. Or even today, you can use Ghidra, and Ghidra perfectly support Objective-C or Swift code. So you have a free alternative today to do so. So yeah, something a little bit complicated when you start is everything is an object. It's how it works iOS device. So you have like a lot of objects and you don't really have a clear workflow. So if you are used to reverse C++, you won't be shocked. But if you are not, it could be a little bit complicated at the beginning, and everything is based on event. So an event, an action, an event, an action. Yeah, some example here. We have a class name WebSF. You can see. I don't know if WebSF, and a method named WebLDLNK. Web download in this case. Another really useful tool is Frida. Frida is a tool for doing dynamic instrumentation. So it's like a debugger. But for example, you can make some really interesting stuff, like when you go in a specific function method, you can get the argument. When you go out, you can get the output, the result of the function. And it can be really useful if you don't understand the function. You can at least check what kind of argument is at the entry and what kind of stuff go out of the method. Here is an example. So I take the same method, so WebSF and web something, download. And I've got encrypted data here. So yeah, you can, in this specific case, you could do it statically. It's not very complex, but it's just for the example. So you have, you enter on the function, it does some magic decryption, and you have a value at the end. You can do it with Frida. So I simply say, I want to attach to this specific method. I want, on enter, I say, okay, I'm inside of the method. And when I go on leave, I print the value of the object. And here you can see I'm inside of the function. Here is the output of the function. So you can see it's a URL. The purpose of this function is to decrypt a C2 server, a URL. So using Frida can be really useful if you want to make some automatization about this kind of stuff. Another approach could be to do it directly on the iOS framework. So each time I use URL method, so provided by Apple, I check the argument and I display the argument. So here I can directly have the domain. Because each time the malware tries to connect to the C2 server, I will display the C2 server. So it's really convenient to use Frida for this kind of task. Yeah, the only big issue on Frida is they only support JavaScript. Don't ask me why. You have a native debugger provided by Apple named LLDB. It's really close to GDB, so if you are used to use GDB, it could be interesting for you. To be honest, I don't like it. I think it's really hard to read. The syntax is mystic, and I don't like it. But I did exactly the same thing. Breakpoint at the specific method, show the disassembly code, breakpoint at the end, get the value at the end. I've got my URL. So it's exactly the same approach, but yeah, I think it's overcomplicated compared to Frida. But it works. Some other stuff you can use. You have FreeDump, which is a Frida script that dumps the memory of the current process. So it dumps the memory during the execution, and you can check the generated strings. And in this case, for example, you will have the URL directly in memory, and you can directly get it from the memory dump. It can be an interesting approach. Something else you can do, and you should do if you analyze iOS device, is to listen on the network. How I work at home, I got my phone, I got a router dedicated to research, and I got a burp and a pickup. So I'm able to have a full pickup during my analysis if I need to replay it, or if I want to check the communication. And if it uses HTTPS, which is almost all the time today, I use burp and I do man in the middle with my own certificate. I trust the certificate on my phone, and I'm able to have all the HTTPS requests. It's not dedicated to iOS. You can do that on Windows. It's the same idea, but really do that. Have a pickup and an HTTPS man in the middle interception, HTTP interception. And to be honest, go on the supermarket, buy the cheapest router you can find, but use a dedicated router to avoid noise on your pickup, for example. Only the phone you analyze on the router, and that's all. That's how I work. So, malware deployment. We speak about malware, how to analyze malware. We speak about jailbreak. We speak about a lot of stuff, but how the attackers deploy malware. For iOS, you don't have 1,000 of combinations. You are really limited on the method from my point of view. And you must understand how works an application on iOS. So, first thing, code signing. The application must be signed by a developer certificate. So a developer certificate, you can have a developer certificate, you pay €100 at Apple, they will give you a certificate, and after you manage your certificate on the web page, and you sign your application. It's pretty easy. They do a great job to have something really convenient, because everybody knows certificate is a big shit. You are always lost about the type of certificate, where you need to put it, extra. And here, it's automatically done by Apple. It's really, really nice. Yeah, you have different kind of certificate. Almost all the case I work on, they use ad hoc certificate. What is an ad hoc certificate? When you are a developer and you are developing an application, you don't want to put it on the store because you don't want people to download your application. It's under development. So something you can do is create an application, and inside the certificate you say, this application only works for this specific device, based on the UID. So each device has a unique ID, and you say, okay, the application is signed for this specific device. Almost all the time, the malware I saw use the same approach, ad hoc certificates. Yeah, there is an example of of a developer certificate named Cambridge Universal Academy, and it's install a fake Instagram application in Arabic language. So it's an example of a certificate. If you look at the application, the Arabic Instagram application here, you can see it's an ad hoc, and you have the UID of the targeted devices. How you get the UID? You can get it on the phone directly, and if you don't have access to the phone, you can create a fake web page, and by using profile, you can get the UID of the people that go on the website. You must have a user interaction. It's not magic. So you have a pop-up on your iPhone saying someone would like to go to get your ID. Are you sure you want to give your ID? Everybody click yes because it's easier. And the attackers have the ID of the device. You have a plist file inside of each application that gives a UID I just mentioned, for example, and you need to set up a minimal OS version and app name, for example, Instagram or whatever. So that's basically how works an application. Plist, that says the minimal requirement, and you sign your binary and the application with a developer certificate for that. For the deployment, for example, you have MDM, so mobile device management. So we identify malicious MDM, so MDM maintained by bad guys with few registered phone on the MDM. We don't know at this time how the phone was registered on the MDM. We have two hypotheses. The first one is social engineering. You call the guy, explain you are support from Apple and you should do that, or whatever. Or the other approach is they have a physical access to the phone. With a physical access to the phone, it's 20 seconds to enroll a device on MDM. Yeah, I can show you. Just 1 second. Yeah, it's... I don't know if it works. Yeah. Next time I will write the second. Yeah, so you have the device, and you will see the number of interaction you need from the user's point of view to enroll the device on the MDM. It's a lot of interaction. So first you need to download the profile. Yeah, it said to you, yeah, you are trying to open the profile. Are you sure here is a profile? You need to install the profile. It's enrolling. You have a warning. You must trust the certificate. So it's a lot of steps to enroll. So you cannot do it very by accident. You need to, really good social engineering or physical access to the device. So if you wait a little bit, what will be the first task of the MDM? Take a few seconds. Few long seconds. Yeah. App installation. So a mobile device manager is able to deploy application on whole device. It's exactly what do company. You have an iPhone, you enroll your phone on your corporate MDM, and after your company is able to deploy internal application on your phone. It's the main purpose of MDM. In this case, you can see two WhatsApp applications installed: the real one and the malicious one. Yeah, if you want to check on your device, you can go directly on the device, on settings. You go on the bottom and you have device management entry where you have all the servers that can manage your phone. It's really easy. If you don't have the menu, it means you don't have any, you are not on hold on an MDM. Apple simply hides the menu if it's not relevant. Yeah. So the other way to install application is to use 0-day, but it's very expensive. It's really limited to specific actors. We saw WhatsApp vulnerability a few weeks ago, so it exists. But it's a hard way to do it, but it's a more silent way to do it. So it depends on the actors, of the money of the actors, of the skills of the actors, but it's a way to do it. Here I put the Zerodium price list for iOS, for mobile. And the price is a little bit lower now, I think, but it was a price like 6 months ago. So let's speak a little bit about the malware analysis and what you can do. First thing, some applications are encrypted by the Apple DRM. So it's the application is from the store. Apple sometimes use DRM, so you must jailbreak the device and use a script named bfinject. It's on GitHub, you can download it. And he will execute the encrypted application and take the unencrypted version from the memory and package it for you, and you will have the unencrypted version of the application. So it's really, really simple. The most common technique I saw in my case is this free one: library injection, WebKit interaction, and custom keyboard. How works library injection? So you have a huge community of people that make tweak on application. What is a tweak? They take a legitimate application, patch the legitimate application with new feature. For example, on WhatsApp, you can only have one account per phone. So some guys take WhatsApp and did add the support of multi-account. So you have two tabs, and you have account 1, account 2. As it's not supported by WhatsApp, a guy did it. You can download it. It's a developer certificate, extra. You can install it on your phone. And it's not malicious, really. I checked the application. It really do what the developers say. You have the support of 2 WhatsApp. But some other people use exactly the same tricks of tweaking application to add malicious code. Basically how it works, you have the application, you have a library, and when you compile the application, you say, okay, you will load the library when you execute the real application. For the attacker, it's really useful because he doesn't have to write the original application. He takes the real one and simply inject a library inside of the real one. So for the users, it's really hard to detect if it's a real one or not, because in fact, it's the real one patched. You have open source project that explain you how to do this task. It's not really complicated. And the point is, when you are inside of the application, if the user uses this application, which is a fake one, as the malicious code is executed inside of the application, he has access to the data of the application. So if WhatsApp, for example, log chat on the phone, the malicious code will have access to the repository where all the information are logged. So the malware can simply get the file and exfiltrate the file to the attackers. It's natively support, and it's like that. Another thing we saw, it was a fake Instagram application, and the application was really light. It was simply a browser going on Instagram.com, nothing else. The application download the HTML code of Instagram, but patch it, add some JavaScript inside. And there is an example where they use a trick, they create an event, and when the users click on login, the iOS application take what the users put inside of the fields and send the information to the attackers. So basically the purpose is to steal credentials. So we discovered this application on a store used in Iran. Because, yeah, it's another joke. On some country, due to US sanctions, they cannot have access to the legitimate store in US. But as they must use their phone, they create a local store, and they use a local store with fake copy of real application. So it's where we found this malicious Instagram application. So yeah, it's basically what I explained. other thing we discover, it's less aggressive than the previous one. We identify click fraud. So I explained to you checkrain, the exploit, and this the jailbreak, and this jailbreak is not released yet. The guy is on Twitter, posts a lot of picture about how the work is going on, and they can jailbreak this version, so they are really they make a lot of communication, but the source code is not available, and they register checkrain.com with a 1. Because it's the name of the project. Another guy registered checkrain.com with an I, not with a 1. And said, yes, I provide the checkrain jailbreak. You simply need to download this profile, and once you download this profile, you will have a jailbreak on your device. You don't even need to connect it in USB. It's magic. In fact, if you look at the profile, the description is simply fake, and it contains a web clip. A web clip is for Apple simply a bookmark. A bookmark on your desktop. So here is what it is for real. So when you install the profile, this icon is on your phone, checkrain, and if you click on it, you will see the attackers was really creative. In fact, it's simply a bookmark to a website. And you will see the website. If the video want. Yeah. So you can see it's in full screen. So the advantage of web clip is you don't see the browsers. So it really looks like a real application. And, it check rain, click on the button. It check your device, which is wrong. Check version. It's simply JavaScript. It does nothing. It's just visual. And after he load your preference, whatever it means, exploit in your kernel, get random memory, doesn't match my memory. And it's jailbreak. Congratulations. The next step, you will have a fake terminal to look serious, you know. And you need to confirm. You sure you do your backup? So, you have a kind of fake shell. Cydia is a store used by jailbreak on jailbroken device. And it's successful load daemon and stuff like that. And finally, if you want a full jailbreak, please play this game. And when you click on the game you want to install, it reminds you, yes, you need to play 7 days before having your device jailbreak, which is wrong, of course. So, and finally move you to the real store, and you need to install this application, extra, and nothing happens, obviously. And finally, another really funny stuff is, I'm a little bit late, sorry, you can develop custom keyboards. So it's a crazy idea, but Apple support custom keyboard. So you are a developer and you say, I don't like the Apple keyboard. I want to use a magic smiley not supported by Apple. And you can create your own keyboard. So as you can imagine, if you have your own keyboard, you can do what you want with a keyboard. So here you have a keyboard on my phone, and you can see each key I push, you have the value on the left. So it's set to the server. So it's a keylogger, basically. It's a custom keyboard used as a keylogger. And it's supported. Apple did something really smart with custom keyboard. You cannot steal password with that. Because even if you deploy a custom keyboard on your device, if you try to write something on the password field, it automatically switched to the real Apple keyboard. And once you left the password field for a normal text field, it switched back to the custom keyboard. So you can install discussion, you can install chat, you can install username, but you can install password. So it's pretty clever from my point of view. So, I tried to show you all the stuff I saw in real life. So it's not on my lab, just to show you what could be done. All these cases are for real. And Apple is doing a great job from a security point of view, for end user point of view, and it's a lot of effort to become root and make some really bad stuff on the device. But when you are Defender and you know you have 2 WhatsApp on your phone, so which is not normal, it's normally impossible to have 2 WhatsApp on your phone, and you want to do some investigation, you have a huge limitation due to this security put by Apple on device, and you need to be creative. You need to freeze the phone. A few months after there is a jailbreak, you can have the phone extra. So it's a lot of effort, and obviously malware exists on these kind of devices. We have the proof. We identify a couple of different malware. It's documented. You can go on our blog post and you will see exactly where we found it, the group behind, etc., extra. So, but it was not the purpose of the talk to speak about the group and simply to show you it really exists and the state of art from my point of view concerning iOS forensic analysis and malware. And I'm 3 minutes late.
We'll be okay. I'm sure we can make it up. Paul, thank you very much for the talk. Guys, we do. I know we're a minute or two late, but we can take a question or two if anyone has any. We've got one at least. Oh, you're lucky you got a question. Must have been because you dressed up, see?
Yeah, you should try.
Thank you for the talk, Paul. I have 2 questions actually. After exploiting the boot ROM with Checkmate, is it possible to run the dual boot, or is it can we dump the custom firmware? And the second question is like after jailbreaking into the iOS, can you see the user data? I mean, like, is it encrypted?
Yeah, it's a good question because Apple did something else very clever. Is the user's data are not in clear. So you need the PIN to get access to the data, to decrypt the data and see. For example, the SMS are not stored in TextPlain on your phone. It's encrypted. And you need the PIN to decrypt this information. So even if you have Checkmate and Checktrain and you are able to do custom stuff, modify the memory, jailbreak the device or whatever, you cannot have access to the data of the users. It's not possible. You need to have the PIN to decrypt the data. So even if someone takes your phone when you are at the hotel, put USB cable and use some magic stuff, if he doesn't have your PIN, he will only have encrypted data. If he has your PIN, he can steal your data. So the PIN or fingerprint or your face or whatever, encrypt your data. So no, even with this, they cannot access to your data, and you need to reboot the phone and DFU, etc. So everything is encrypted from data point of view.
Cool. Oh, one more. Take one more. Okay.
Just be quick. Is there any good repositories or sources if you're wanting to get into the area or kind of analyze things yourself? Like obviously Windows, other platforms, there's a lot of readily available malware that you can download and look at.
Yeah, in our case, I don't know if the sample we analyzed on VirusTotal to practice. I'm not sure. Maybe you need to check. Or even if you don't work on malware, you can work on legitimate application to understand how it works and to create your lab. You don't necessarily need a malware. Even you develop your own hello world, and you will play with signature, ad hoc certificate, and stuff like that, and you will clearly understand how it works. So you can, if you don't find any public malware, you can do your own hello world and practice. Or you take a Starbucks application. It works also.
Don't take the Starbucks application. Pretend Paul didn't say that. Guys, that's us done. If you want to see Paul, he'll be about.
I will be here for the party. If you have questions, feel free to.
Yeah. Awesome. Cheers, Paul. Thanks very much.